Hey, chemistry folks. This is a Unit 8 stoichiometry problem. We were working on it in class today and got caught by the bell, and I wanted to finish it out with you. I am in OneNote in the class notes tab as well. So if you go in there, you'll see the problem all worked out. This video walks you through the steps in the process. So we're talking about stoichiometry. So we're looking at trying to use a balanced chemical equation to predict product and look at percent yields. We're also using the BCA tables and stoichiometry to take a look at limiting and excess reactants. So this is the problem 5 from worksheet 4. And what I'm going to do is I'm going to go to the big screen here, so I have just a blank page. There we go. And I lied. Let me come back out and get my pen working. There we go. Now, in this problem, it's the copper silver nitrate lab. We take copper metal and we react it with silver nitrate, and we produce silver metal and copper 2 nitrate. So we're going to write out the reaction first. So you get copper. Why is this going to be like this? Copper reacts with silver nitrate. And remember, we've practiced writing these all out. So we're going to have silver metal and copper 2 nitrate, so NO3 2. We need to balance, and so we're going to have a 2 out front here. And we're all set. Now, once you write out the reaction, then we need to take a look at what we're given in the problem and what we're looking for. So it says that we have a mass of copper goes into a tube and reacts with a certain mass contained in a solution of silver nitrate contained in solution. So we're given the mass of both reactants, and we're asked to calculate the percent yield of silver. So this problem takes you through, not only are we calculating our theoretical yield of our product of silver over here, but we're going to also then compare it to what we actually got and try to figure out how our reaction went and calculate a percent yield. So that's at the end of the day, that's what we're doing. So when I see I've got 2 reactant pieces of information, and I'm not being told who is the limiting reactant and who's the excess reactant, that tells me I need to do a BCA table right off the bat. Like I need to do a BCA table to figure out who's limiting and who's in excess. So I'm going to set it up, BCA table, and I'm going to take my grams of copper and my grams of silver nitrate. And remember, we need to convert grams to moles. And at this point in chemistry, while you need to show the calculation from grams to moles, I don't necessarily need to see your calculation of the molar masses of the substances. But I will do it on this video just so that you know where I'm getting all of my information. So I'm going to take 2.93 grams, and that's of my copper. And I'm going to get this to scooch you over for me just a little bit. And the molar mass of copper from the periodic table is 63.55, 63.55 grams in 1 mole. I know I need to put that down there because I need these units of copper to cancel. I do the arithmetic, and sorry, I have my problem worked out already. I do the arithmetic, and I get 0.046 moles of copper. I'm going to do the same thing right now with my silver nitrate. So 141 grams of silver nitrate. Oh my goodness, that's such a sloppy looking thing here. I'm going to convert that to moles, and silver nitrate is 169.88 grams, right? I went ahead and I added up. The silver is 107 plus 1 nitrogen at 14.01 plus 3 times 16 is 48. So 48 plus 14 plus 107 gives you 169. And that's in 1 mole of silver nitrate. And again, I'm doing this a little quick. It's a video. You can pause it, rewind it, slow it down, whatever you want to do. I probably sound real funny in slow-mo, but whatever works for you is fine with me. All right, so these units cancel. I'm going to calculate it out, and I get 0. Where am I at here? 0.0083. I know we've done on occasion, I've simplified some problems and did some rounding, and we talked about that. In these situations, we're going out 3 significant figures. Do not round anything. Carry out all your significance. And, I'm shortening it up by one digit. I really should be going out 1 more place and 1 more place up here. But, if you're asking me for the exact answer, you go out 3 sig figs, and that's how far you carry out your numbers. So let's come back to the problem. So now we got the moles of each of these things. I'm going to come back here, and I don't want to hit my Screencastify thing down at the bottom. I'm going to put it in my before table. I'm in my BCA table in the before column. So I'm going to put 0.046 mole of copper. And then underneath the silver, I'm going to put 0.0083 of the silver nitrate. And in the beginning, I don't make anything. I have 0 moles because I haven't done the reactions yet. And after each number, you need to put mole. Sorry, I'm writing kind of big, so it's messing up my spacing. Now what I need to do, I don't know which one of these is the limiting and which one is the excess. The only way I can figure out whether this one is limiting or this one is limiting is to treat it like it is. So I'm going to pretend that copper is the limiting reactant. I'm going to use all my copper. So I'm going to take 0.046 divided by 1, and which is 0.046. I know that's the same number. 0.046. I'm going to multiply that out through the whole reaction. So if I do that, obviously the change here would be 0.046. If I multiply 0.046 by 2, I come up with 0. And I forget the number. Let me do it real quick. 2 times 0.046, and I get 0.092. I don't have 0.092 moles of silver nitrate. I don't have enough silver nitrate. That means I'm not going to use up all the copper because the silver nitrate is going to limit me to only so much. It's going to be the limiting reactant. So now, oh my goodness, I'm going to use all this up and call that my limiting reactant. And so I'm going to take 0.0083 and divide that by 2. 0.0083 divided by 2. And I get 0.00415. I'm going to take that 0.00415. Very frustrating here that this is, let me hop out and erase it and clean it up real quick. Sorry, y'all. I can't take it. It's looking all sloppy. There we go. So I'm going to multiply my reaction. In theory, I'm multiplying my reaction by 0.00415. When I do that, I end up using 1 times that, right? So I end up using 0.00415 moles of copper. I'm going to do all of my, 2 times 0.00415 is this number. That's how we got the number in the first place. 0.083 moles. I'm going to use up all my silver nitrate. So I'm going to be left with no silver nitrate in the end. And I'm going to make, So 0.00415, right? I'm going to multiply that by 2. I'm going to make, so I'm making plus 0.0083 moles of silver and 0.00415 moles of copper nitrate. So I'm going to do all this arithmetic. So 0.046 minus 0.00415 gives me 0.04185 moles left over of copper. So if I were to take my piece of copper out of the solution, I would still have a piece of copper. If you guys remember, we did the nail lab. You had a piece of iron, or that nail, right? We didn't use up all of the nail. There was nail left over. And we would need way more of our aqueous solution that we put the nail in to produce more copper. If you guys remember, we were making the iron and copper. We were using iron and copper. So it makes sense. I didn't use up all the copper. There's literally going to still be a piece of copper metal sitting in there. But I did make 0.0083 moles of silver and 0.00415 moles of copper 2 nitrate. So the problem, going by, my gosh, I can't believe it, we're this long. The problem said that the student, when they did the lab, obtained 0.87 grams of silver metal. Calculate the percent yield. So that means I need to figure out theoretically from this number of moles of silver, how many grams of silver in theory should I produce? And then this is what I actually produced in the lab. So let me come down here. So I'm going to do 0.0083 mole silver. Convert that to grams of silver. Silver's molar mass is 107.87. Oh man, my nose is running. My allergies are so bad. Sorry. Let me digress. Okay. Oops, I did exactly what I didn't want to do. Put it in the wrong spot. Do as I say, not as I do. Here we go. And that's it, 1 mole of silver. Ta-da! Moles are canceling. I do my arithmetic, 107.87, and I get 0.0083 times 107.87. I get 0.895 grams. And the problem tells me that we obtained 0.87. So 0.87 divided by 0.895 gives me 97. Well, it gives you, remember, it gives you 0.97. I want to convert that to a percent. So multiply by 100, and I get 97%. That's my percent yield. So this problem walks you through all of the things that we've learned so far in chemistry, from writing out compounds to writing out reactions to balancing reactions, and all the nomenclature that goes into it, doing all of your grams to mole conversions, doing your finding the molar masses of compounds, right? It's everything put together. And then we get into looking at the limiting reactant, which is the silver nitrate, and the excess reactant, which is the copper. Now, in some problems, they're going to give you they're going to tell you something's in excess. In some problems, we can just do a T-chart and not even need to do a BCA table. But generally, if you do a BCA table every time, you'll be okay. And then you'll start to recognize when you can just do T-charts, and just convert over. But you'll always need a balanced chemical reaction. All right, y'all, I'm going to stop the video. This was problem number 5 from worksheet 4 in unit 8. I will see you next time. Thanks.